This video is on the remainder and factor theorem. To understand the remainder and factor theorems, we need to review two skills that you already have. One is to use synthetic division to do division like this. Here's our polynomial divided by x minus 2. Our synthetic setup is just to use the coefficients. Don't forget the correct signs. Also, x minus 2, the number you put on the outside of the box is 2. We always change that sign. Bring down the 1, draw your line, and begin multiplying. 2 times 1 is 2. Add these together, we get negative 4. 2 times negative 4 is negative 8. Add these together is negative 4. 2 times negative 4 is negative 8. Add and we get negative 13. Now remember what those numbers stood for. Those numbers stand for a particular polynomial. Since this was x cubed, then this will begin with x squared. And this will be x minus 4. And what this negative 13 is the remainder. More about that in a minute. I want to do f of x equals x cubed minus 6x squared plus 4x minus 5. That is the same polynomial that I had over here. And I want to evaluate f of 2. To evaluate f of 2, I need to put 2 in for all of those x's, which is what I've done over here. Here's all the arithmetic worked out. 2 cubed minus 6 times 2 squared, etc. Do the arithmetic. 2 cubed is 8. 2 squared is 4 times the 6 that's sitting there. 4 times 2 is just 8 minus 5. Finish out this arithmetic and we get negative 13. The function value at 2 was negative 13. The remainder when we did synthetic division was negative 13. That's what the remainder theorem says. It says if we do synthetic division on a particular number, the remainder we get is the same thing as if we had evaluated the function at that number. One thing to emphasize, this is 2, this is 2. There is no sign change going on between those two values. The only sign change is this. When you were using synthetic division and this was x minus 2, the number we used on the box out here is a positive 2. So what the remainder theorem says is if polynomial f of x is divided by x minus c, then the remainder is f of c. Now that sounds confusing, but that's exactly what we did back here. Our polynomial was divided by x minus c, so in this case 2 was our c. There was our remainder. When we did f of 2, we were actually doing f of c. So that's what the remainder theorem says. So let's do a couple examples with this. It says use synthetic division and the remainder theorem to find the indicated function value. So all I'm going to do is my synthetic division. Put a 3 on the outside and put my coefficients 2, negative 4, 5, and negative 2, and then let's just do our synthetic division. Bring the 2 down, draw your line, and begin. 3 times 2 is 6, add gives me 2. 3 times 2 is 6, add is 11. 3 times 11 is 33, add, and that gives me 31. So that says the function value of 3 equals 31, which we'll check this on the next screen. This is doing the arithmetic. Here was our synthetic division. There was our remainder of 31. This is just plugging 3 in for each of these x's and doing the arithmetic. And you can follow through on that arithmetic and see that we get 31. One more like that. Let's do our synthetic. Negative 2 on the outside with 1. Incidentally, just keep in mind when you're doing synthetic division to be sure that you don't need a placeholder. We don't, but you won't always look for that. So let's multiply. Negative 2 times 1 is negative 2. Add gives us negative 7. Negative 2 times negative 7 is 14. Add gives us 19. Negative 2 times 19 is negative 38. Add those together, we get negative 43. Negative 2 times negative 43 is a positive 86. Add that together and we get 80. Notice I quit writing the x cubed, x squared, etc. because all we're concerned with is the remainder. Let's check it out. Doing our arithmetic, this is plugging in all of those negative 2's for all of those x's and working this out. Now you decide what is easier arithmetic, just doing that pretty simple synthetic division or having to raise numbers to powers and multiply and add things together. Now if you have a calculator like the graphing calculator that you could just plug this into the calculator, that's pretty easy. But if you don't have a calculator that does arithmetic so easily for you, then the synthetic division is a very good method. You will also see at the end of this video or the next video why synthetic division is so helpful with these polynomials. Now let's look at what's called the factor theorem. The factor theorem says let f of x be some polynomial. Two things are true. If f of c equals 0, then x minus c is a factor of f of x. This works the other way around. If x minus c is a factor of f of x, then that means f of c equals 0, which sounds confusing, but let's take a look at an example. Let's take a look at this. Solve by factoring. We would factor this as x minus 6 times x minus 2 equals 0. Now I haven't finished solving it yet, but we solved it by factoring. That means these are factors. X minus 6, x minus 2 are factors. Now if we continue solving and set each of these equal to 0, we have x minus 6 equal to 0, and we have x minus 2 equal to 0. Solve, add 6 to both sides, and we get x equals 6, and we get x equals 2. Those are our solutions, but you also might remember from a previous lesson, these are also called zeros of the function. Now evaluate f of 6. If you put 6 in here for x, you're looking at 6 squared minus 8 times 6 plus 12. 6 squared is 36, 8 times 6 is 48, plus 12 gives me 0. That's why this is called a 0, because if we evaluate f of 6, we get 0. Same thing's going to happen with 2. 2 squared minus 8 times 2 plus 12. Do the arithmetic. That's 4 minus 16 plus 12 gives us 0. Now go back to the c's and the x's and stuff so you understand what's what. If f of c equals 0, okay, in this case, c was 6. It equaled 0. That means that x minus 6 is a factor, and it is. It's right here when we factored it. If f of 2 gave us 0, that means x minus 2 will be a factor, and it is. So let's get a couple things straight. These statements are analogous. X minus c is a factor of the polynomial. Means that c is a 0 of the polynomial. It also means that c is a solution or root of the equation. So here's a function, x squared minus 5x plus 6. We know that factors is x minus 2 times x minus 3. So x minus 2 and x minus 3 are the factors of the polynomial. If you set these each equal to 0, then we're going to get x equals 2, which is a solution, but it's also called a root or a 0. Set that equal to 0 and solve, and you get x equals 3. So that when you know you have a factor, you also have a 0 or a solution. So let's say x minus 6 is a factor. That means automatically that 6 is a root or a 0, or you could just call it a solution. Now, if it said x plus something like x plus 5 is the factor, then that means negative 5 is your root or 0 or solution. We're going to see some problems in the next video where we are dealing with knowing a 0, and we're going to use that to help solve the rest of the polynomial.